Hi students, once again welcome back to our lecture series on polynomials. In our last lecture we have seen the relation between zeros and coefficients of a polynomial, and we have also seen how to form a quadratic polynomial and a cubic polynomial from its roots or from its zeros. See, now today we are going to discuss some board examination questions based on these topics. See, those who didn't watch my previous videos on polynomials should watch it first. Otherwise, you won't be able to understand today's class. See, I have told you earlier that we are mainly focusing on board examination questions. So, in each and every topic, we will do as many board examination questions as possible. Okay, let us go directly to today's topic. See, in our last lecture we have seen that for a quadratic polynomial, ax square plus bx plus c is the general form of a quadratic polynomial where a not equal to 0. So let us assume that alpha and beta are the zeros of the polynomial. Alpha and beta. So this is a quadratic polynomial. Quadratic polynomial is nothing but a second degree polynomial. Second degree polynomial will have how many roots? Sorry, how many zeros? 2 zeros are there, alpha and beta. So we are assuming that alpha and beta are the zeros of this quadratic polynomial. Then what will be alpha plus beta? Alpha plus beta is nothing but sum of the zeros. And sum of the zeros will be minus b by a, and alpha into beta is the product of the zeros, that is c by a. We have seen this result in our last class on polynomials. See, ax square plus bx plus c where a not equal to 0 is the general form of a quadratic equation. Sorry, quadratic polynomial. See, a quadratic polynomial, since it is a second degree polynomial, it will have 2 zeros. We are assuming that alpha and beta are the zeros of this quadratic polynomial. Then we have seen sum of the zeros, that is alpha plus beta, is equal to minus b by a, and product of the zeros alpha into beta is c by a. And also in our last lecture we have seen how to form a quadratic polynomial once we are given the zeros of the polynomial. For that we have the equation x square, we have the equation x square minus sx plus p. How to use this equation? X square minus sx plus p. What is s? S is the sum of the zeros. And what is p? P is the product of the zeros. That is x square minus sum of zeros into x plus product of zeros. So using this expression we can form the quadratic polynomial from its zeros. So if alpha and beta are the zeros of a quadratic polynomial, what will be the quadratic polynomial? X square minus sum is alpha plus beta into x plus alpha into beta. So if alpha and beta are the zeros of the polynomial, then the quadratic polynomial will be x square minus alpha plus beta into x plus alpha beta. See, we have seen these results in our last lecture. Now let us go directly to problems. See, the first problem is find the quadratic polynomial with sum and product of its zeros are respectively 1 by 4 and minus 1. Here we are required to form the quadratic polynomial and we are given the sum and product of the zeros. See, how will you find out the quadratic polynomial from the sum and product of the zeros? X square minus sx plus p equal to 0, where s is the sum of the zeros and p is the product of the zeros. That is x square minus, if alpha and beta are the zeros, x square minus sum is alpha plus beta, or s equal to alpha plus beta into x plus alpha into beta is the product which is denoted by p. So what is sum here? Sum S is equal to, S is the sum of the zeros, sum and product of the zeros are respectively 1 by 4 and minus 1. So sum of the zeros is 1 by 4 and what is the product of the zeros? Product of the zeros is minus 1. S is equal to 1 by 4 and P is equal to minus 1. What is the expression for forming the quadratic equation? X square minus Sx plus P. X square minus Sx plus P. X square minus Sx plus P. So this is X square minus, what is S? S is the sum of the zeros. It is given directly. 1 by 4 into X. 1 by 4 into X plus what is P? P is the product of zeros. Product of zeros is given as minus 1. So here this is X square minus 1 by 4 X plus minus 1 becomes minus. Here the signs are different. If the signs are different, we will put a negative sign. If the signs were same, we would have put a positive sign. So X square minus 1 by 4X minus 1 is the required quadratic polynomial. See, in order to get rid of this by 4, we can multiply this quadratic polynomial throughout by 4. So that we can get rid of this 4. We can multiply this quadratic polynomial with any non-zero constant. So let us multiply this polynomial throughout by 4 to get rid of this by 4. Okay, so 4 into x square, that is 4x square minus 4 into 1 by 4x minus 4 into 1. 4 into x square minus 4 into 1 by 4x minus 4 into 1. That means we are multiplying each and every term of this quadratic polynomial by 4 to get rid of this divided by 4. So simplifying this, we will get 4x square minus, here we can cancel this 4. So we will get 4x square minus x minus 4 is the required quadratic polynomial. So here we are given sum and product of the zeros as 1 by 4 and minus 1. That is S equal to 1 by 4 and P is equal to minus 1. How will you form the quadratic polynomial? X square minus Sx plus P. X square minus S is nothing but sum of the zeros. Sum of the zeros is denoted by S here. 1 by 4x plus P is minus 1. So we are multiplying throughout by 4. Here plus minus becomes minus. So x square minus 1 by 4x minus 1. To get rid of this 4, what we are doing is we are multiplying this throughout by 4. 4x square minus 4 into 1 by 4x minus 4 into 1. That is 4x square. Here 4 can be cancelled. So 4x square minus x minus 4 into 1 is 4 is the required quadratic polynomial. See, now let us move to the second problem. See, this problem is taken from the latest examination paper, that is CBSE 2020. See, if the sum of the squares of 0 of the quadratic polynomial f of x is equal to x square minus 8x plus k is equal to 40, find k. So this is a quadratic polynomial and it is given that sum of squares of zeros of the quadratic polynomial is 40. We are given sum of the squares of zeros. So let us assume that alpha and beta are the zeros of this polynomial. So this is a quadratic polynomial. So a quadratic polynomial will have two zeros. So let alpha and beta, be the zeros. So what will be alpha plus beta? What is alpha plus beta? Which is minus b by a. So what are the values of a, b and c? See, this is ax square plus bx plus c. So what is a here? A is the coefficient of x square. means 1x square. Therefore, a is equal to 1. And what is b? b is the coefficient of x, which is minus 8. And what is c? c is the constant term, that is term independent of x. c is equal to k. So what will be alpha plus beta? It is minus b by a. That is minus, what is b? Minus 8 by a is 1. So minus minus 8, same sign, becomes positive. So minus minus 8 is plus 8. 8 by 1 is 8. So alpha plus beta is equal to 8. And what is alpha into beta? Equal to c by a. And what is c? c is equal to k by a is equal to 1. c by a, alpha into beta is equal to c by a, but that is k by 1, that is equal to k. Now we have got the results. Alpha plus beta is equal to 8 and alpha into beta is equal to k. Using the standard results, we have seen that sum of the zeros is minus b by a and product of the zeros is c by a. We are assuming that alpha and beta are the zeros. See, it is given that sum of squares of zeros of quadratic polynomial. What is meant by sum of squares of zeros? See, what are the zeros of the polynomial? Alpha and beta. Isn't it? Alpha and beta are the zeros of the polynomial. So what is meant by sum of the squares of zeros? See, alpha and beta are the zeros. Therefore, its squares are alpha square and beta square. What is meant by sum of the squares? Alpha square plus beta square. See, alpha and beta are the zeros of this polynomial. It is given that sum of the squares of zeros is 40. So alpha and beta are the zeros. Therefore, its squares are alpha square and beta square. What will be the sum of the squares? Just add alpha square plus beta square. And the sum of the squares of zeros of the polynomial is 40. Alpha square plus beta square is equal to 40. And we know that alpha plus beta is 8 and alpha into beta is equal to k. So what is a square plus b square? So we know that a plus b whole square, a plus b whole square is a square plus b square plus 2ab. So a plus b whole square is a square plus b square plus 2ab. So what will be a square plus b square? Or in other words, a plus b whole square minus 2ab is equal to a square plus b square. So a square plus b square, a plus b whole square, this plus 2ab is brought to the left hand side. It becomes minus 2ab. A plus b whole square, this plus 2ab is brought to the left hand side to become minus 2ab. Is equal to, here on the left hand side we are writing a square plus b square as it is. So what is a square plus b square? It is a plus b whole square minus 2ab. You just make this identity by heart. A square plus b square is a plus b whole square minus 2ab. So what will be alpha square plus beta square? It is alpha plus beta whole square minus 2 alpha beta, that is equal to 40. So alpha square plus beta square is of the form a square plus b square. And what is a square plus b square? It is a plus b whole square minus 2ab. See, a plus b whole square is a square plus b square plus 2ab. We are transposing this plus 2ab to the left hand side. So it becomes minus 2ab. So a plus b whole square minus 2ab. In the right hand side we have a square plus b square. Or a square plus b square is a plus b whole square minus 2ab. So a square plus b square is a plus b whole square minus 2ab, and that is given as 40. For a and b, here we have alpha and beta. Now we have the results for alpha plus beta and alpha beta. What is alpha plus beta? It is 8. 8 square. Alpha plus beta is 8. So this is 8 square. 8 square minus 2 into, what is alpha into beta? Alpha into beta is k is equal to 40. So this is an equation containing only one variable k. So we can easily find out the value of k. So what is 8 square? 8 into 8. 8 square is 8 into 8, that is 64. Minus 2k is equal to 40. Now let us transpose this minus 2k to the right hand side, and we are bringing this plus 40 to the left hand side. So 64 we are writing it as it is. 64 plus 40 when brought to the left hand side becomes minus 40 is equal to this minus 2k becomes plus 2k in the right hand side. So 64 minus 40 is equal to 2k. So what is 64 minus 40? 64 minus 40 is 24. That is equal to 2k. Or 2k is equal to 24. So what will be k? K is equal to 24 by 2. That is k is equal to 12. Is it clear to you? So it is given that the sum of the squares of zeros of quadratic polynomial f of x is equal to x square minus 8x plus k is 40. So we are assuming that alpha and beta are the zeros. What is meant by sum of the squares of zeros? See, the zeros are alpha and beta. Squares of the zeros are alpha square and beta square. And what is meant by sum of the squares? Just add alpha square plus beta square is equal to 40. But a square plus b square is a plus b whole square minus 2ab. You have to make this identity by heart. A square plus b square is a plus b whole square minus 2ab. So alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta, that is equal to 40. And what is alpha plus beta? It is sum of the zeros, which is 8. 8 square minus 2 into, what is alpha into beta? Product of the zeros, which is k, minus 2k equal to 40. So 8 square is 8 into 8, 64, minus 2k equal to 40. So this is minus 2k. So we are transposing this negative 2k to the right hand side, becomes 2k. This plus 40 is brought to the left hand side. 64 minus 40 is equal to 2k. Or what is 64 minus 40? 24 is equal to 2k. That is 2k is equal to 24. If 2k is equal to 24, what will be k? K is equal to 24 by 2. That is k is equal to 12. See, this question is taken from the very latest question paper of CBSE, which is CBSE 2020 question. See, I have told you earlier that in this series we are mainly focusing on board examination questions. So in each topic we will complete as many board examination questions as possible. So I think these two problems are quite clear to you. So in our next video, we will discuss some more board examination questions based on the topics which we have seen earlier.